Okay, let's slowly get started. The start's a little slow just to kind of let people turn up. One thing I'll say up front is that, like I say, I am from Scotland. I'm aware I have an accent. I do try to speak slowly and clearly. If at any point I'm going a little too fast, which happens when I get excited or get into something, just say in the chat. I can see the chat. I will slow down. I'm absolutely fine with being slowed down. So just say slow down. Okay, let's get going. So this is probably not the start that you expected for this talk. It is about TDD. We are going to get there. It is also about shame. So TDD is my shame being the title is important. But we're going to start with this. This is a Sudoku puzzle. It's a pretty simple idea that can be quite complicated if you're not used to it. As you can see, it's a 9x9 grid separated into 3x3 boxes. And you solve this as a puzzle by placing the numbers 1 to 9 exactly once in each column, each row, and each 3x3 box. Yeah? Hopefully, most of you have at least seen a Sudoku puzzle before, whether you've done one or not. I remember them first becoming popular here in the UK when I was at university. So that was, a while ago, a good little while ago. Various newspapers would print them beside the traditional crossword puzzle. For the younger people, a newspaper is like a printed version of the internet, but usually more accurate. Usually, I always found these Sudoku puzzles frustrating. I found them frustrating for reasons I'll get in a second. So this one here, the one you can see, was graded as easy. Of the 81 cells, 38 are already filled in. So you've got about half the work done for you. And most people, given the rules, can figure them out with a bit of time. I'm pretty sure if we looked at this for a few seconds, we could see, if you look at column 3, column 3, row 7, a 5 can go in there. And I can tell that because of where some other 5s are, just by very quickly looking at it. It doesn't take very much time to spot that for me as somebody who's done these before. These were not the ones that frustrated me. These easy ones were not it. This Sudoku puzzle was graded expert. There's only 23 cells that are pre-filled. It's much harder. As you can see, like the entire middle box has no numbers pre-filled in it. How do you fill this in? I thought it was pure witchcraft, and I gave up. In the immortal words of Bart Simpson, I wasn't good at it right away, so I quit. I didn't even study. I honestly didn't even try all that hard. I just wasn't naturally good at it, so I didn't bother. Hopefully that resonates with at least some of you, that you had that experience in something in your life. So I'm kind of going to talk about how you go from being able to solve the ones on the left, the easy puzzle, to the ones on the right, the expert puzzles. And at this point, you're probably wondering which talk you turned up to. Don't worry, this talk is TDD Is My Shame. So my name is Gary Fleming. I am a software developer. I'm an agile coach. I am a meetup organizer, a conference organizer based here in Scotland. I focus on how people can improve writing software, whether that's from a people and process point of view or from a software crafting point of view. I kind of look at both sides. That is my Twitter handle at the bottom there, at Gary Fleming. If you like what I say and you mistakenly believe I will say other things that you will also like, that's the place that I'm likely to say them. We'll find out. So we're going to start with shame. A journey into shame. Hopefully everyone was prepared to hear a little bit about shame given the title. We will get to the TDD stuff quite quickly, but it really is important that you understand this bit on shame. So I run a meetup here in Glasgow, Scotland called Codecraft that focuses on craft or writing good software. Don't worry, this is not a pitch for that meetup. It's just where the story starts. I wouldn't expect people to start turning up. A few years ago, we were running a session on it was either mob programming or pair programming, getting people to work together to solve problems. I don't know exactly what happened, but there was an unusual argument that broke out. One of the groups, there was clearly an argument, some people being unsettled, and it kind of dissipated before we could leave the groups we were working with and go over and make sure everything was okay. We weren't able to figure out what went wrong. Afterwards, as is our want here in Scotland, because it's grey and miserable, we don't get good weather, we went to the pub, because if you're going to bring joy in your life, you're not going to get it through sunshine, you might as well get it through beer. One of the attendees, who I'll call Paul, seemed perturbed. Perturbed, that's a funny word. Why did I pick perturbed as a word? When I asked him what was wrong, he mentioned that he was feeling some imposter syndrome. And I'm certain that most people have felt some form of imposter syndrome at some point. Oh, somebody's having cloud for issues. Sorry about that. Paul looked deeply uncomfortable in a way that one only can when their worldview's been crushed. The argument had made him realize something. It was clear that he'd been involved in this argument, and the argument had made him realize something. He said this to me. He said, "I'm a little ashamed, but I don't TDD as much as I think I should." And there's a lot packed into that sentence. There's layers and nuance and meaning. I don't TDD as much as I think I should. That's a complicated emotional response. And since that conversation all those years ago, I've spoken at a number of conferences and meetups around the world. I spoke a good number of times in the US last year, speaking in Europe, speaking in the UK. And as a consultant, I also get to go into a lot of different companies and see people with different backgrounds, different ages, different ethnicities, just lots and lots of different people. And I've started asking them the same question when I can, when it's safe to, when it's appropriate. I ask them, do you TDD? I'm kind of curious. Say just yes or no. Most of the time in the chat, most of the time, do you TDD your code? Got one yes, I know. Okay. Another no. No. Nope, I need to learn more. Interesting. Good. Good. Okay. This is, I mean, I've done this talk a few times now, and this is almost always the response. There's usually one or two that are like, yep, I'm a TDDer and I do it all the time. And then the vast majority of people don't. I probably would if my entire team did. Yeah, that is a big problem, and we will come back to that a little later on. While I don't know anyone who does it all of the time, well, one person claimed to. One thing that's become very clear to me by asking this in all these different contexts is the number of people who routinely do TDD is minuscule. And I mean really minuscule. It's a tiny fraction of a percent. And it appears to be getting smaller. There's less and less year in year that it's getting smaller. Somebody saying, but it is a difficult aspect to measure. What is enough, too much, not enough? Yes, we will. That is a very good question, and one that we will have to get to. Sorry, I dropped my thing I was fidgeting with. How much is enough, and how much should you do? We all get to that. Probably the worst thing about this idea that people are doing it less and less is it is regularly accompanied by shame. In some form or another, people feel they ought to do TDD, but they don't, and they can't often articulate why. So let's spend a few minutes talking about that. What is shame? What is shame by itself? Now, let's be clear. I am not a psychologist. I am not a psychiatrist. I'm not a therapist, so I'm going to tread very lightly. Shame is rooted in vulnerability, but it manifests in many ways. A number of things can contribute to the experience of shame. So this is not a definitive list, but I found it on, I think, Psychology Today. I think that sounds about right. About a number of different ways that that can cause us to experience shame. So sometimes it's like a simple faux pas, like turn up to a social event wearing casual stuff where you should wear formal. Sometimes it's looking for the cause of something and not finding the cause, so naturally just turning and blaming yourself, which is faulty logic, but very common. Sometimes it's breaching some sort of standard convention, like laughing unexpectedly at a funeral. It's actually very common to deal with stressful situations through laughter and a humor response, but again, people feel shame about it afterwards. And it can be low self-esteem, directing things going wrong at yourself reflexively without even looking for the cause, just kind of blaming yourself. That is really what low self-esteem is. So there's a great TED Talk, which if you take anything from today's talk, it would be go watch this TED Talk at some point. Not right now. I'd prefer you stayed for the next half hour or so, but write it down. Listening to Shame by Brené Brown. It's worth watching because it calls attention to how shame manifests itself differently for men and women. I can't actually see a list of attendees, so I can't even remotely guess what the male to female split is here. The people have commented they appear to be male, just going in the names. Again, they might not be. I'm not trying to draw any judgments there. But shame does manifest itself differently for men and women. For women, shame for women is this web of unobtainable, conflicting, competing expectations about who we're supposed to be, and it's a straitjacket. If this is not something that you recognize, it might be worth speaking to more women about the pressures that they feel that society puts on them. We expect them to be, perfect mothers and have great careers and put all these many different and various pressures on them that you cannot possibly meet all of them. You just can't. And the natural consequence of not being able to meet baseline societal expectation is shame. For men, it's actually much simpler. In almost all cases, shame in men is caused by one thing. It's just one notion: don't be weak. And a whole bunch of societal damage has been done and continues to be done by the self-reinforcing idea that men mustn't be weak. That is pure toxicity. Men shouldn't be weak. That is a cause of a whole bunch of problems. Now, I'm not going to talk about that any further. That's a whole talk by itself. It's maybe hours and hours and hours of content. But be aware that any time that you're feeling shame, it's usually because, if you're a man, it's because society expects you not to be weak in some way. And it's okay to look at that and go, no, I am okay just by myself. So what are these developers experiencing when they say they don't do TDD, and why? It probably really is shame. It's yet another thing for them to do that they don't. So a reminder of their lack of perfection, or a way that others who are their peers might perceive them as weaker. So I want to start this talk by just saying, you're good enough. Whatever I say for the rest of this talk, you don't have to do any of it. We're going to talk about TDD like almost for the entire rest of the talk, but you are good enough already. Do what you can to improve. If you can't, don't worry about it. Your own sanity, your own mental health, everything else is more important than you getting better at TDD. Improve at your own pace, and that is absolutely fine. You are good enough. Deep breath, and beer. So, as I said, this is an easy Sudoku. The strategy you use to solve an easy Sudoku is honestly just usually grid scanning. If you look at column 2, row 4, I can tell you that a 1 goes there. I can tell you a 1 goes there because in rows 5 and 6, there are 1s already, and in column 1, there's a 1. So in that box, the only place a 1 can go is there. If you put the 1 in there and you continue scanning for the other numbers, you will get this done pretty quickly. It's a very simple technique. It's really powerful, and it will get you solving easy Sudokus in minutes. Like really, this should, if I tried to really solve this, I could probably solve the whole thing in about 60 seconds. It would not take me long. It would maybe take you a little longer if you're inexperienced, but the basic technique works. So where are we going to begin with TDD? I've spent a long time so far not talking about TDD, so it's time to do that. There's lots of places we could begin, but let's begin here. What is it? Is it a testing practice? No, not really. If you speak to any testers about the idea of modern testing practices, they will not know TDD in the slightest. And they're right. It's not a testing practice, even though it involves testing. Tests aren't the point in and of themselves. They're a useful outcome, but they're not the purpose of TDD. Is it a design strategy? Maybe. It's a starting point, but probably not sufficient. Is it development practice? Yes, probably, almost certainly. So I like this quote by Anthony Marcano, who said, I would say TDD is a software development practice. Design, coding, testing are all elements of software development. Too often development is used synonymously with writing code, which does the definition of the word a disservice. And I think that's a really important key here. Writing code just by itself, churning out code, is not software development by itself. Just churning out code endlessly, that is production code, is a liability. Code has a cost. You should write as little as you can and ensure the code you write is well designed and well tested. So the idea of software development tends to be wider than most people think. So it's also worth saying up front that there really isn't one thing called TDD. We like to pretend that TDD is a thing that you can just do, that there are some rules that you can follow, and then you will be doing TDD. That isn't quite true. The practice involved and the processes people do all just kind of mush together. Yeah, they come together in a weird way. Ron Jeffries, who was one of the original Agile Manifesto signatories, says that's how ideas are. They're mushy. It's like a bunch of different Play-Doh making up something. You just kind of squeeze together until you've got a shape. Where would it be the same if you took bits away? Yeah, probably, maybe, who knows? There is no one true TDD. I like how Liz Keogh describes TDD. Liz Keogh, if you don't know her, was one of the early pioneers in BDD, behavior-driven development. She helped write JBehave, which was a predecessor to things like Cucumber. She described it as an anchor term. So TDD is a useful anchor term because it's searchable. If you want to know more about TDD type things, like tools and processes and ideas, you can type in TDD into Google and you will get a bunch of reasonable articles. It's an anchor term. It's something that we can all get around. So TDD isn't unit testing, but it helps you understand it first. First of all, what is a unit? So in the chat, what do you think a unit is? What do you think we mean when we say we're unit testing? On a side, Chris, we're saying 89% of software developer time should be analysis and design, 10% coding. If that's done correctly, which certainly includes a TD approach, one can get a better product. I would somewhat agree with that. I think there's times where you know the domain very well, and using a TDD loop is maybe shifts the design around. But yeah, I mean, way less time coding than a lot of people think. So JR is saying a small piece of code that does something. Okay, that's for a unit. Does anyone else got any idea what a unit is? No more approximations. Oh, sounds like a good definition to me. So people are agreeing. Cool. So what was originally meant when people came up with the term unit for unit tests? So unit test is a small piece of code that has no outside dependencies. That's actually a really good definition. The truth is, right back at the start when they were come up with this definition, no one agreed, and they still don't. So the people who were involved in it, which I think was people like Kent Beck, Ward Cunningham, maybe Ron Jeffries, not sure, all had slightly differing opinions on what a unit is. So if anyone tells you they know what a unit is, they're mistaken. There is really no solid definition. The one thing they did agree on, and as far as I can tell, still do agree on, and I did do a bunch of research for this talk, is that this is what is necessary to do a unit test. So as Marty's saying in the comments there, it has no outside dependency. So it cannot talk to a database, it cannot go over the network, and it cannot talk to the file system, right? These are really important things. If you go over input, output of any sort, you are not doing a unit test. You're inherently, intrinsically tied to the rest of your environment. It must be parallelizable, and it can't have any weird environment setup. So by weird environment setup, it might mean other software pre-installed or outside of the necessary things for your language, or it might mean something like the clock has to be at a certain point in time, or something odd in your environment. And the reason that these are the necessary requirements for unit testing is that that's what's needed to make them fast and isolated, reliable and deterministic, repeatable. These are the characteristics you want from good unit tests. And if you don't do this, you'll get flaky unit tests. And flaky unit tests are worse than no unit tests. As soon as things get flaky, people stop running them. If people stop running them, they very quickly lose value. Sandy Metz, who is my coding hero. If you don't know Sandy Metz, she wrote a book called Practical Object-Oriented Design in Ruby. Do I have it here? Yes, I do. So this book here, even if you don't write Ruby, and I imagine probably most of you don't, buy this book. It's very understandable for Java programmers, Python programmers, JavaScript programmers. You don't really need to know Ruby, but it's an excellent, excellent piece on design. Anyway, she says that unit tests should be thorough in the sense that they are logical and complete. You know, you're covering everything that you have to cover. They should be stable, so they don't break when implementation details change without also changing the behavior. They should be fast, so if they're not fast, they don't get run, and if they don't get run, they cannot lose value. So they have to be fast. And few. There should be as few of them as it should be as small as possible to express what we need. So few, but also thorough. There is a little tension there, and one of the tricks is finding the right biting point. Now we know what a unit test is. What is TDD? Is it writing the test first? Very often people think that's what TDD is, but that is not the case. One of the most common practices I see people go wrong with, and that causes their tests to become brittle, is they write the whole of the test up front and then write the implementation. That is not TDD. That is test first design, and it's better than not doing it. It is better than not doing it, but it isn't TDD. I don't want to be too pedantic or panicky in this section. We will go and kind of explain what TDD is. In fact, we'll do that right now. The first thing a TDDer will usually tell you is about the red-green refactor loop, where you start by expressing the idea that you'd like the code to do that it currently doesn't do by writing a test. You're focusing at all times on the what, not the how. The idea behind the code, not the implementation. And we do that by first writing, making our code go red. And there's really three ways that we can make our code go red. I did have a fourth at one point. I cannot for the life of me remember what it is. I wrote it down in a notepad that I lost. I have no idea what the fourth thing is. So now there's only three. The other one's lost to time. So in our test, we can write an assertion failure. So we might say that we expect that variable x equals 4 after we do some work. So an assertion failure would make our test go red. Hopefully that is understandable, easy to see. That is the most understood version of TDD. Not the only thing though. It can also go red if there's an unexpected exception thrown. If the code that we are exercising throws an exception that we expected, that's cool. It's not red. That's fine. But unexpected exception implies that we have more work to do. But the most fundamental and most important one that a lot of people miss is missing code. If I write a tiny bit of my test code to call a class or a function or a method that does not yet exist, my IDE will make that little bit of code go red to say that method doesn't exist, Gary, or it doesn't have that parameter yet, or that class doesn't exist. That is enough to make it go red. As soon as you get red for any of those reasons, you stop writing test code. Yeah, and you go and make that red not red anymore. So you haven't written the whole test yet. You might have even just written the first line. So if we were doing a bowling scorer game that kind of calculates a score for a bowling game, 10-pin bowling, I might say scorer dot calculate. And if the calculate method doesn't exist, well, I stop right there. I haven't made any assertions. I haven't checked that it works yet. I already have a problem. I need to go and fix that. The next stage is green. And green is actually the simple part. You do just enough coding to stop the red. So in that case, I might write a stub method for the calculate method. Doesn't do anything, doesn't really cause any new behavior. It just makes that thing not go red anymore. And then we go back around the route to refactor. So refactor is the interesting one. So refactoring takes its name from factoring in maths. If you're aware of factoring. If you're not, that's okay. Let me explain it to you. You can see that the top numbers here, 5 times 291 equals 1455. Trust me that that's true. You can go and check it for yourselves if you really want to have an exciting afternoon, but it is true. We can also break down that 291 into factors. So 3 times 97 equals 291. So it logically concludes that 5 times 3 times 97 also equals 1455. So when we say refactoring in code, what we're saying is we are going to change how the code is together in pieces into smaller pieces or into different shaped pieces without changing the behavior. So having gone red and then green, you're moving pieces around without ever going red again. Yeah, you're not breaking anything, you're not changing any behavior, you're not adding new behavior. You're just doing enough to move pieces around to clean things up and make it neater. So common gripes that we very often see. I like this quote by Marco Rogers. If there's one thing we should always do when we're doing TDD, it is making sure that we always see a failing test. If we write a test and it never goes red at any point because perhaps the functionality actually has already been implemented and we did not expect that, we should have a look at that and figure out why. Our test might be totally fine, but we should see it fail. We might introduce an error into the test and then make sure it fails in the way that we expect. Because sometimes if you don't do this, you find that the thing that you're testing isn't actually being tested properly. So the lack of error you're getting back or the lack of failure signal you're getting back isn't because you're testing the right thing. So you must always, always, always see a test go red first and then make it go green. That is not something you can ever skip. Another common gripe is the loop should be much smaller than you think. This is much easier if you're working in a domain that you know, on a problem that you know how to solve. But the TDD loop should be much smaller than you think it should be. If you get a bunch of people who haven't done TDD before, very often that TDD loop will be minutes to tens of minutes, which is very painful to watch. If you get somebody who's very experienced in TDD, who is working on a code base that they know, on a problem that they understand, the loop is tens of seconds. 30 seconds around the entire loop, that would be normal. That would be perfectly fine. Again, I did put a bunch of caveats in that. Another very common gripe is that people think refactoring means rewrite. As I said earlier, refactoring is not a rewrite of your code. It's just moving pieces around. Rewriting your code, it implies that you're going to break interfaces, potentially change behavior that is observable. No one should know from outside observation that your code has changed when you're refactoring. And very often people forget to refactor. And that's really a dev thing. A lot of devs are so motivated by getting the next requirement done and the next requirement done that they don't necessarily see the immediate value in refactoring, but refactoring has huge, huge value. If you're not refactoring as you go through the TDD loop, at least every couple of iterations around the loop, you're going to generate a huge mess of code. You're going to generate a massive technical debt that you're not going to be able to fix later. It's very important that you refactor as you go. One of the things that is probably not commented on that much is that red-green refactor isn't enough. Yeah, you have to use thought and judgment. There's times where a red-green refactor doesn't make sense, or where you need to put in your own design input or your own influence. You have to think. TDD is not an abdication of thought. You still have to think. You have to be designers. What it does is help you. And I also think there's a very important part of the red-green refactor structure that we don't really think about, which is selection and naming. By this, I mean when we select a requirement to go and implement. So if we select a requirement to go and implement, it's important that we all agree on what it is and that we choose a good name for it. This is especially important when people pair or mob program. I've seen far too many times where people are pairing and they're each implementing different requirements. So the pairing goes very awry because you never really had a clear conversation to say, this is the requirement we're tackling right now. And naming. And yes, naming is hard, as JR is saying in the comments. I think it was Phil Carlton, famous computing scientist, said, the two hardest things in computing science are cache invalidation and naming. This remains true today. It's always been true. Naming is hard, but it's really important that we do it and try to do it. But we're doing it based on the knowledge that we have when we try. It's very hard though. I mean, I like to go for clear naming. I would also encourage you, your test names, don't think about them as function names, even if they are written in a function. Think about them as sentences. Yes, cache invalidation, naming things in off by one errors. That's right, Thomas. I do like that variant on it. Think about your test names as sentences. So when I take an action, then I expect an outcome. Or given the world is in some state, when I take an action, then I expect some sort of outcome. I wouldn't be worried about being too wordy in your test names. I would go for it because it brings clarity and documentation to your tests. Okay, another deep breath. We've got the basics done. So this is a medium difficulty Sudoku. To solve this, I might be able to use some of the same tricks as before. So third row from the bottom has a 3 in column 2. And I can see that again by using the same scanning technique on the 2 rows below it. But that's probably only going to take me too far. I'm probably going to have to use techniques like last remaining cell, where you fill in all the possibilities for every possible cell and then start crossing them out to figure out where things go. It's a bit more time consuming, but you eventually kind of figure it out. An interesting thing about that technique, when you figure out how to do the last remaining cell, is you've learned something new for the medium, but if you take it back to the easy puzzles, you'll be able to do them much faster. The things you learn later go back to even the easier stuff and make you better at doing them, which is kind of interesting. So that's the basics of TDD. A starting point, somewhere to get going. Let's talk about some of the common issues people have with TDD and when you should maybe not do it. What issues do you have with TDD? If you want to shove them in the comments. We already had somebody earlier say that their teammates don't do it. And yes, that is a huge problem. That's a very, very common problem with TDD. What other problems do you have doing TDD? Lack of examples are not just Hello World. Yep, that is very fair. Like a real life not console app. Yeah, that is true. I actually tried to find some good full application sized examples of TDD that were in a public context, and there aren't many. The Cucumber code base, if you're familiar with that, has some pretty good examples. as you might expect from people who are kind of test adjacent. Keeping them clean when there are lots of scenarios to set up, yeah, that can be a pain. It can be a pain. Okay, these are common. These are the kind of things that I would expect. I'm going to go into the next bit. Well, I want to be clear on one thing about TDD. I am not dogmatic about it. Yeah, I don't demand that everyone does TDD all the time. If TDD is the wrong tool for the job, you shouldn't use it. Yeah, replace it with something else. A major issue, though, I see is the developers don't seem to replace it with anything. It's mostly just haphazard. They don't necessarily design anything. They code away and maybe add some tests later. There's no real practice. And by practice, I mean a series of steps that other disciplines would recognize as, oh, that is a practice. I mean, I like to think about it this way, right? Imagine that you had to build a fence and you did it by chopping up bits of wood. And then you dug some holes and you nailed some of the wood together and shoved that nailed together wood in the holes. Then you started measuring. You measure and notice that the wood doesn't quite fit all around your boundary. You rip parts of it off and nail new parts of the wood in. You then realize you've run out of wood and nails. So you go to the shop to buy more. You come back and then just start hammering in different places. That really wouldn't be seen by a woodworker or a handyman or a joiner as practice. That would be amateurish. I think we can agree on that, right? Just not having the discipline and knowing the steps to build a good fence. That's what most people do when they're coding. And I'm not saying that you should absolutely do TDD. I'm just saying do some sort of practice. Do something that would make the code that you do professional and understandable from a practice point of view. Whatever you want to do. I'm genuinely not dogmatic about TDD. Do something. But it's slow. Yeah, that's a pretty common reaction I hear. And writing the test is overhead. It's something that you now have to do that you didn't do before. Having to refactor everywhere in the lean sense of the word, and in terms of lean Kanban, is waste. Is it though? For relatively straightforward cases, you might be able to write your initial code a little bit faster, granted, but will it be as maintainable? Will it be as well designed? Will it have more or less bugs? Will we spend more time debugging later? I think very quickly, in the short to medium term, you'll find that TDD isn't slow. It's much faster. But that takes time and discipline and practice. I mean, and that time and discipline part is kind of important. It's important that we understand that learning new things takes time, and it takes time to implement them as practice. So imagine for a second, hopefully you can see this curve here, which is based on a curve by Virginia Satter, who was a family psychologist, but her work has been applied widely to practice and change, so getting better at doing things. Imagine that whatever you do, let's say it's programming stuff, let's say it's programming code to sell toilets. Currently, the amount of money you make is this green line. Hopefully none of you are colorblind. I should have thought of that. I apologize. The lower straight line, the green line, that's the amount of money you're making doing that just now. And your boss comes in and says, if everyone starts to code in Spanish, the upper line, the blue line, is how much money we're going to make. When that change is introduced, what's going to happen? It's going to go badly wrong for most people, unless you already speak Spanish. Some of you very well might. I don't. It's going to follow this red line. It's going to go down into a ditch. And it's going to go down into a ditch because I don't know what I'm doing. I can't speak Spanish. And unless I bring in expertise, unless I spend time learning, unless I make a concerted effort to gain that discipline to learn Spanish, I'm never going to come out of it. And very often, as we learn a new practice, we are in that downward tail. And as we're kind of getting in the bottom, we panic and stop and just give up. We do a BART. Instead, we need to get that expertise, give ourselves time so that we can get better. I mean, there are also plenty of times when doing TDD doesn't make sense. I've been told more than once about people trying to write tests for ID-generated getters and setters. If your code is trivial, you don't need any tests. Coverage is not a goal. If you've got ID-generated getters and setters, I wouldn't bother testing them. Ron Jeffries doesn't TDD when it's like a simple throwaway thing, because the overhead isn't worth it. There is really no maintenance cost for trivial code, and I mean truly trivial. If you can look at it and within a second go, that's a getter, that's a setter, that is a wither, that is a builder, you don't need a test for it. If you can understand it that quickly, adding tests is not going to help. He also doesn't do it when there isn't a decent tool at hand. His example was he's been programming video games on Kadia on his iPad, which is like a mini coding IDE, which is pretty cool. So when he started doing that, he couldn't really write tests, so he didn't, which is fine. Like, it's genuinely fine. There is actually now a version of XUnit called Kadia Unit that you can use, but that was then. It can happen though. He also doesn't do it when the output is visual. If you've ever had to compare two images or do something that is truly visual, it is a pain, an absolute pain to unit test. I would suggest that you isolate all the business logic that generates that code and test that, and then just leave the little rendering thing on the edge of your system untested. Because actually comparing the visual output is incredibly painful. I've done it a few times. I've seen some AI solutions there. It's very costly. It doesn't get you much if you've already got the business logic well tested. And he also doesn't do it when he can't think how to test something, which I think is an incredible admission. It's fantastic to hear somebody has experience saying that. If you just don't know how to do it, it's fine. Maybe you'll learn somewhere else. Maybe you'll be able to come back. Don't beat yourself up too much. It's fine. Do what you can. And maybe you also don't want to do it because you prefer larger methods with less focus, or you don't know how to keep the test look small, or you don't know how your system should behave. That last one there, the first two are kind of a little facetious, but the last one there is actually true. I've worked with people doing machine learning, and they really don't know how their systems should behave. That doesn't apply to everyone. It applies to very few people. They don't know how it should behave, though. Try to isolate the rest of your system from those less predictable parts, test the predictable parts, and then think about a wider testing strategy for your harder test parts. Another deep breath. So, it's hard to see the subtle differences between medium and hard. There are fewer numbers still. At this point, you might fill in notes for every square and use stuff like pairs in rows. If two numbers can only appear in the same two boxes, then you can use them to isolate other boxes. If you're not following that, don't worry. There are other ways of doing kind of row, column, and grid-based eliminations based on minimal constraints. It's about kind of negative information. You are playing with information that you don't know as well as what you know, and kind of whittle away possible outcomes. This is where it starts to get tricky. But again, once you learn those techniques and you take them back to medium and easy, they also get easier. At the point I started doing hard Sudokus, I managed to get my medium times down from about 10 minutes to about 4 minutes. Such is the power of learning more advanced techniques. I want to make sure I covered some kind of intermediate advanced topics because, I expected most people wouldn't have done TDD, so we've hopefully covered a lot of that just now. But I want to make sure we talked a little bit to people who have done a little TDD. That will still be valuable for those who haven't, but maybe less clear how to apply. So this is Kent Beck's 4 elements of simple design. He says that this is what you need to do any good design. A TDD is a design practice, as we talked about at the start, and a development practice. So it has to pass the test. Hopefully that is obvious. If your code doesn't pass the test, something is wrong. I should say this is ordered, by the way. Top one's most important, bottom one's least important. It reveals intention. So by revealing intention, we mean that it's easy to understand. It is well named, which we accept as hard. and it communicates itself. It communicates its ideas. It communicates what it should be. You should be able to look at it and go, yeah, I get this. No duplication. So don't repeat yourself if you can possibly avoid it. Now, there's a little caveat to go on that one about not repeating yourself. Sometimes you don't want to you don't want to dry up code. You don't want to remove duplication too early until you really understand the nature of the duplication. And fewest elements. Remove anything that doesn't serve the others. So this is sometimes referred to as KESS. Keep it simple, stupid. So keep it very, very simple. Do as little as you possibly can. So there's a debate in the order of the middle two elements. There's a well-known TDDer called JB Rainsberger, who has a great article in which he goes over this in some detail. You can see his whole argument online, and please go and look at it. I can't remember what the article is called, but if you search for JB Rainsberger TDD simple design, you will find it. The too long didn't read though is basically this: remove duplication and improve your names in small cycles, which kind of speaks to what we were talking about before about how naming's hard. If you just do these two things repeatedly in your TDD loop, your code will get better. Remove duplication slowly and improve name cycles. And personally, I'm a sucker for better naming. It is very hard to do, and it's something that we should do iteratively as our own knowledge of the code and the domain increases. I try to think about it every time I go around the loop, or at least every few times. I think hard about the appropriateness of the names I've used. I also try to make sure that the names are appropriate on the abstract to concrete list spectrum. I guess spectrum is what I'm looking for here. And try to come up with more concrete names. Now, most of the names I've put on here, I think are bad most of the time. I mean, if you're naming your classes or methods object or instance, you're really telling us nothing about them. Similarly, for things like process or builder or request or command, what are they building? What are they processing? What are they creating? These are more important than the names of patterns we're trying to put in. My most hated is manage. I hate managers. It's very often that you have sort of noun manager patterns, especially in old code like Java or C#. Like if you've got a login system, you have a user manager. I would much rather see more a bunch of smaller separate things like user finder or user searcher or user creator or other things that are very small and very specific rather than manager. It doesn't really tell us whether it's searching or finding or creating, and very often becomes a dumping ground for all of the above as they start to appear in our systems. I would discourage the use of most of the names that I've got on the screen just now. So good names avoid unnecessary ambiguity. They don't have too many things that aren't concrete or that aren't relevant to the domain that we're talking in. They are just concise enough to convey the relevant information and no more. We want them to be short, but no shorter. And that's hard, but time and practice, you'll get there. And most importantly, it should use the shared domain language as much as possible. Rather than bring in technical jargon, more of our names and more of our classes and methods should be understandable by our business people. I mean that, like, shared domain language is incredibly important to developers and businesses and everyone involved in the process of software development. Share your names, use the domain language, not technical language. So, expert. So, what does it take to solve an expert level Sudoku puzzle like this? It takes all of the tools that we talked about before, and some few rare specialized tools. So there's a whole bunch of weird name stuffs in the world of Sudoku I've learned in the last year. It was about a year ago I started doing these on a trip to Detroit for a conference up there. Down there, from my perspective, you're a good few hundred miles below me. The weird names like Bowman's Bingo or Y-Wing or Lobster Claw or all sorts of other weird stuff. And you only need to use them rarely. But as you start to learn them, you put them in your toolbox, and then at the right moment, you bring them out. So to learn to be good at Sudokus, you need learning. You need to actually put in a little bit of time. You need studying. You need to put in concerted effort on things that have been created. You need to seek new tools. Find the next step, the next thing that you can go and pick up. You also need time and deliberate practice. It's not going to just happen for you. You need to make time and find that deliberate practice. And I'm sure that this is going to come as no surprise, but the reason we've been talking about Sudoku all this time is this is true for many things in code, and it's especially true of TDD. You need learning, studying, take time to seek new tools, and practice. No one's expecting you to be great at it on day one. You will be bad at it. I promise you, you'll suck. It'll be horrible. People might laugh, and they shouldn't, but that's okay. You're getting better and you're improving. And honestly, if you don't have the time to do any of that, don't worry about it. Don't feel any shame. You are good enough. You're good enough the way you are. I promise you that. If you do have the time, you can become an expert. There's no inherent TDD ability in human beings. We have not evolved that quite yet. All the people who are great at TDD have just practiced. But if you don't have time, that's okay. Right, that's a talk. Thank you very much. As I say, at Gary Fleming is my Twitter handle, and my if you go to that bit.ly link, bit.ly/TDD-shame, you'll get all of the slides. I'm happy. I've got another like 9 minutes. I'm happy to take questions. Happy to chat. If you don't want to do it here, you can DM me. Whatever works for you. If there's any questions, though, I'm happy to take them. Scotch or bourbon? I prefer whiskey, which is not spelt with an E. So I guess what you would call Scotch, but whiskey, no E. I was at a whiskey distillery about 2 weeks ago, but I couldn't go in because it was 6 in the morning and I was climbing a hill, cruelly right next to a whiskey distillery. It was nice on the way back though. 4.5 hours later, that lovely Scotch whiskey smell. Any other questions? You're right. I guess not. Well, thank you very much, everyone, for coming. Like I say, if you want to ask any questions privately, somebody's asking, how's the developer job market in Scotland? Generally pretty good. This year, not so good. I mean, obviously, we have an ongoing global pandemic, which is having economic consequences. That's not amazing. We are also part of the United Kingdom, who decided for, well, I'm not going to the politics of this, but decided that next year, in January, that we are going to leave the European Union, which is going to have further economic effect. So right now, it's kind of middling. The job market's not as good as it's been. It's not bad though. There's plenty of kind of big companies like Amazon, JP Morgan, Morgan Stanley, Barclays, Skyscanner, Fangio, a whole bunch of kind of small and kind of medium-sized tech startups. You can basically you can find pretty much anything you want to do, unless it's really, really esoteric. If you wanted to find a closure job, you could do that years ago. Those places have mostly disappeared right at this moment. Hopefully that answers that. So GR is asking, what are some good ways to get dev team started? Design patterns, refactoring, or just getting right any red green refactor? If they're genuinely new, I would suggest don't let them do it anywhere near your production code. Carve out an hour or two a week to do code kits. So picking a problem and going and working it. And I mean that in the nicest possible way. If you let them go and work on your production code and they don't know how to do it, it'll make things worse, and they'll get frustrated, and then they'll blame TDD rather than their own lack of knowledge. It's more important that they learn that skill first and get that muscle going, and then start to slowly apply it to your code base. And once everyone's got some of those muscles built up, you'll find it much easier. So like carve out an hour or two a week. I like doing it first thing Monday morning, like 9 o'clock Monday morning. Let's go on and work on a problem together. There's a million katas out there that you can go and work on. And you'll find that even if you've done one before, you can do it again and try it in a different way or with a new constraint. Like let's do the bowling game kata, but let's not use if statements or any conditionals. That can be an interesting twist. So just practice, 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 get the skills, and then try to slowly introduce it. I'm glad that makes sense. Okay. Well, if there aren't any other questions, I'm going to go. Like I say, if you want to ask me a question in private, I know it can be a sensitive topic. I'm happy to take your questions on kind of Twitter or anywhere else you can get a hold of me. Thank you.